My name is Navin. I'm a research scientist at NVIDIA, and I work on multimodal synthetic data generation software and approaches. And yeah.
I'm Lipika. I work also on synthetic data generation, but more on the privacy side. And so we'll see multiple things today: multimodal data, privacy, and just like a whole pipeline, start to finish.
Yep. So we've got a couple of resources for you to get started. So there's this repository on GitHub. I'd encourage you to open it up, clone it. Right. So there are instructions in the README on how to get set up. But if you could clone it and get started, that would be great. I'll just keep the screen on for a few more minutes so you get a chance to copy or type it up. While we do that, the other thing we need for this exercise are a couple of API keys. These are the ones this repository is set up to work with. So there's one from NVIDIA API key. You can get one for free from build.nvidia.com. It's free, but with a caveat that it's rate limited. So it's good for small scale experimentation. It's not really meant for production scale data generation. You could also use OpenRouter. You can create an account there, get an API key. If you want to use their paid models, the cost incurred during this workshop is going to be very minimal, probably $1 or $2 at most. And the same thing with OpenAI. If you want to use OpenAI, they're usually faster because they're production grade API providers. So if you want to use that, or if you already have an OpenAI API key, it'll work as well. So key thing to note is that you want to have these API keys either exported to your shell environment, or you just copy it to, you follow instructions to copy it to, or put it into the .env file. So folks who just trickled in, just make sure you copy this GitHub URL and look at the quick start README to get started. But while you do that, because we like to multitask, we're going to get started. So this is about synthetic. The title is From Synthetic Examples to Production Signals, Multimodal Data, Training Data Pipelines with Privacy-Safe Feedback. What does that mean? So at the end of the day, what we want to do is we want to build good synthetic data visual question-answer pairs to help train a visual language model to reason about what's in a document. How do we answer questions about documents that have rich content like text, dense text, tables, charts, and tables. And then we want to fine-tune our own model based on that data to get better at answering questions of that document type. And then once it's fine-tuned, we want to put it in production, right? So once we put it in production, we're going to get a bunch of traffic from people using it. But the flip side of that is once people start using it, they're going to put all kinds of privacy PII information in their input. Like when you use ChatGPT, you might put names, the date of birth, and things like that. But the data that we collect from production is super useful in creating a data flywheel where we get more usage data. We want to use it in further training so that our models get better. But before we can do that, we want to make sure that we make it privacy safe. We want to remove PII and stuff like that. And Lipika is going to talk in detail about that.
Yeah. And just to clarify, so during the session, we'll talk about the data parts, right? We're not going to fine-tune a model.
Yeah.
We're not going to go through that exercise. We're not going to obviously deploy this to production. But we're just going to assume like all of this has happened in the middle, and we'll do the two bookends of generating synthetic data to train the model, and then figuring out, well, we got these logs. How do we even make them safe for us to understand how people are using our model?
Yep. So we'll get started with a few slides introducing the two open source libraries that we're going to cover, NEMO Data Designer and NEMO Anonymizer. And then we're going to walk through 3 notebooks in progressive complexity. The first one's going to be sort of like intro to data designer. We're going to learn some key concepts about the library specifically. And then build a very simple text question answer generation pipeline. And once we have our intuition on that particular topic, we will extend that to other modalities. And this specifically, we're going to extend to vision. We're going to work with images that, in fact, is also generated using Data Designer synthetically. So we'll talk about that a little bit later. But then once we have that, we have another notebook to cover privacy aspect of that. So, and then we can take questions at the end. But if you have any questions throughout the talk, please feel free to raise your hand, and we'll be happy to answer those questions and make sure you're following along.
Yeah, and if you're stuck, just like reach out, just raise your hand or ask for some help. We'll come around, and we have a lovely volunteers in the back helping too. So.
Yeah, just real quick again. So you want to have one of these ready, either NVIDIA API key, OpenRouter API key, or OpenAI API key. Here's the URL. Git clone it. There are instructions. It's really simple. Clone it. Go into that directory. Just do make setup. It's gonna use UV to set up your environment. Download all the dependencies, and then do make lab. It's gonna spin up. It's gonna spin up the Jupyter Lab environment, and a browser is gonna open. So let's just do that real quick. So I have everything downloaded. So all I'm gonna do is make lab.
Increase the size.
Oh yeah. This is fine. So once you do make lab, we're going to have a Jupyter environment spin up here any second, right? So once you get this, we're all ready to go. So we can get started. Anyone having any issues with setting up their environments? If you don't want to set that up, feel free to just like follow along as well. So it's going to be very, we're going to run notebook cells, and we're going to progressively go through the steps. So before we do that, while you do are getting set up, I just want to ask this question to these folks, like how many of you are still awake? Just kidding. Everyone's awake. It's the end of the day, so everybody needs coffee. But I'm kind of curious, like how many of you know about how LLMs are made? Like, do you know about the stages that go through? Just by a quick raise of hands, like, do you have intuition around those concepts? A few head nods, and okay, yeah. We can cover this real quick.
Yeah. Okay, so I mean, we all use Claude, we use ChatGPT and Gemini. Gemini just sort of happens by default these days, but we all use this, right? And all of these are like built on LLMs. Sure, everyone doesn't need this super basic introduction, but just so we're all on the same page. Typically, for example, at NVIDIA, we train Nemotron models of like all different sizes, a few billion parameters up to like many hundreds of billions of parameters, and all the way up to trillions of parameters as well. And so across the board, large language models or vision language models are built in a very similar way, like the fundamental building blocks are roughly similar. The first is data collection. There's just a ton of data on the internet. There's Common Crawl, there's Wikidata, there's so many different sources that are available. Many of them are open, many of them are not. Data tends to be the strategic advantage of model builders and model providers. And so like, there's a huge emphasis on data collection, data curation, and that's a lot of what we work on. But the reason it's important is because we go through all these different phases of generating a model that's actually able to provide all of us, users of Claude, Gemini, whatever surface you're using, something useful. And there are several stages involved in getting there. There's pre-training, where you're just literally teaching the model how to predict the next token. And we've all heard of next token prediction and so on, but this is like the fundamental first step of training an LLM. After that, we want to make sure that the LLM is good at following instructions, just basic instructions. That's the step of fine-tuning or supervised fine-tuning. Also, like quite fidgety, you sort of have benchmarks that you want to hit. I want to do really well on coding, really well on math, but then also question answering, being able to understand what's in documents and PDFs, right? Like what is in a table, that type of thing. And so you want to be able to follow instructions as a model. Then there's a step of reinforcement learning. So that's sort of how would humans respond to a question, or if it's something like maths or coding, where there are multiple right answers potentially, or multiple ways of getting to the right answer, you can have some sort of ranking system, right? Like something is more efficient than the other, and you want to prioritize the efficient thing, and that's the process of doing reinforcement learning, where you say, okay, you have multiple options, this is the top one, and then train the model to do that better. Or there are new flavors of this, like RLVR with verifiable rewards, or GRPO, or just in general, like, how do I make a car bomb? You don't want your model to provide an answer to that. So things like safety as well. So go ahead.
Yeah, the way I think about it is just like, analogy to painting, right? When you're painting something, you use wide brush strokes first, like get the little concepts in, and then you go in with a finer brush to add the details. So same concept with pre-training, fine-tune, and RLVR.
Yeah.
So hopefully that gives you some context. I guess like the other question is like, why do we need to generate data if you already have tons of trillions of data? And the answer is like the LLMs, they're data hungry. You can give it as much data as you want, but it's never satisfied. But the other flip side of that is we have tons of data, but like the tail end of the distribution of data that we have is very low, and you sort of like, it's very expensive to generate that data using like human annotations or other strategies. You sort of have to use synthetic approaches to fill that gap, and that's where Data Designer comes in. So NEWA Data Designer is an open source general framework that we open sourced about 5 months ago. We've been using it for over a year and a half or so like that. But it's a general framework. It's what I mean by that is use case agnostic. So if you want to do text to SQL data set, text to Python, right? If you want to generate like question answer pairs to improve a VLM, if you want to generate just like random like knock jokes, you can use Data Designer. So it's use case agnostic. It's very modular and extensible. It comes with some batteries that you can use. It's like you can use Data Designer to satisfy like solve different kinds of use cases. But if you have some like bespoke use case that requires you to use your own like stack, for example, let's say you have a weird physics simulator that you want to use in your synthetic generation pipeline, we have a plugin system that's really well-rounded that you can use to build a wrap around your system that then plugs into the Data Designer's execution system. From scratch, what that means is like is when you don't have any data, you want and you want to start from scratch, or you have some like seed data set that you want to ground your generation on, then you can use Data Designer. So yeah, you can just install pip install Data Designer or UV add. Some quick stats. So it's only been around. So this telemetry is based on like 5 months of usage data. We've already it's already processed around 2.5 trillion, 2.6 trillion tokens overall. 2.1 of that is context, which means given as an input to the models, and then about 0.5 trillion tokens that's coming out as generated, and significant portion of those tokens have gone into Nematron models that have come out. And this is over like 1.2 million jobs. Quick breakdown, and this is stats that we already share periodically in our GitHub README pages. Looks like so far Gemma 4 is quite popular, and Quen models that come through. Star history, like we had some like few spikes, viral moments that went up, but overall we have a pretty organic growth of people giving us GitHub stars, and we have a significant PyPy base install of like close to half a million install base. So it's growing organically. Like if you like it, go ahead and give us a star and show us support. We already always appreciate that, and even better, if you want to contribute, go ahead and open up a pull request or anything like that. Question?
What's the jobs?
Yeah, so whenever there are two kinds of jobs in Data Designer we'll talk through later. It's like a preview job and a create job. Preview is like you want to iterate quickly to see what your data looks like as you're designing it. And create is when you want, when you're happy with your job, your pipeline, and you want to submit a massive job. Like say you want to generate 1 million records, then then this is a accumulation of both of those stats.
Yeah.
Yep.
And SDG is what we the acronym we use for synthetic data generation.
Thank you.
Yeah.
Water. Let's move on. So we've used Data Designer internally at NVIDIA quite a bit to contribute to all three Nematron Nano, Super, and Ultra. Ultra was the largest model that was released yesterday, and it's and all the models are truly open. It's not just open weights. It's open weights, open data, open recipe, open pipeline, open everything. In addition to the Nematron Super Nano and Ultra, we also contributed to Nano. And these slides will be shared later, but you can see the benchmark improvements that the data contributed to.
I would say like we can dwell on this a little bit more, because within NVIDIA there's so many different ways of like getting data. I mean, it's a huge company, right? Like we by no means do we know everyone who's working on data collection problems, but it's really awesome that they're using a tool like Data Designer, which isn't even like, it's not like NVIDIA says, okay, this is the only tool that you can use. We're pretty tool agnostic across the board, but internally as well, we're able to show like tremendous value with something like Data Designer, which is very, very easy to use, very easy to customize, and we have folks internally and partners who like build things on top of Data Designer. And and even like our anonymization services built in Data Designer. So it's like very extensible, and we have such tremendous usage, and it's like the results are pretty crazy to be able to have tremendous jumps on these benchmarks that are really hard to begin with. Is like it's really like I think a big testament to how easy it is to use Data Designer.
Yeah, and it's quite scalable too. So you can go from generating 10 records to 10 million records. The framework supports that. And two, I guess, benchmarks I'd call out here is the search tool calling accuracy, where it literally went from 0% accuracy to 31%, 31.28%, which already is low, but if you compare that with other open source models that are in the same family, it's pretty close to that. The other one is the last one at the bottom, long document understanding. We contributed around 2 million records, 45 billion tokens, and it improved that particular model. So in this case, it's like Nematron 3 Nano Omni. Omni means it can handle text, audio, video, and image in the same context. You can give it in the same input, and it can give text output, and it improved that performance on long document understanding, which is a benchmark that measures like how can it reason about content across like hundreds of pages and being able to answer the question by about 2.2x. One call I want to make is like we have, and the core team of Data Designer and contributors regularly contribute to developer notes, and these are technical posts that folks make about new features that they added, technical deep dives, or it's about success stories. Like in this use case, like we talk about some of our learnings, like what we learned, what are things that are good, that are bad, things like that. So if you're like wondering about how can I use Data Designer or a tool like that, what are some of the use cases, you can go to DevNotes to get an idea of how you might find helpful. But before that, like you might be wondering, like, can I just call an LLM, in a for loop and get my synthetic data? And the answer is yes, but you're going to get terrible data, right? And to use my example earlier, if you were to ask an LLM to give you like a knock-knock joke, right? Have you ever done that? Like maybe a million times, maybe not a million times, but maybe you'll be able to, if you did it like 1,000 times, you'll start to see that even though LLMs are stochastic, like you can't deterministically generate the same thing, you will still start to see patterns and things that it repeats, right? And that's an artifact of the training that it saw, the data, the patterns in the training data that it saw during training and fine-tuning. So we don't want that. And when you're working with synthetic data, diversity is super important, right? So we don't want to lock into specific patterns. We want to have lots of data, very diverse data, so that model can generalize over these data sets, as opposed to overfitting to a specific kind. And to do that, what you want to be able to do is steer these LLMs to generate the kinds of data that you want. So in this case, the first here, it says generate customer profile. If you just said that, it's up to the LLM's imagination to give you that data, right? It's going to be unpredictable. But if you said, generate a customer profile for someone who's 30 years old and has a German Shepherd and lives in London, you're going to get a different response. And that's the kind of steerability we want in a framework. And imagine like you want to generate 100 million records, and each the permutations has to, being able to permute over like many different variables like that is super important. And the other important thing is correlations, right? In this example, you generated a customer, that's fantastic, but if you want a product, it says generate a product that the customer would buy. So, but what I'm interested in this is like the customer has to be the one that you generated just now, right? So you want to be able to correlate between records. Validation and verification is important. You can generate records, but you should be able to verify and validate very quickly. Let's say you're generating some Python code. You want to be able to execute that and then validate that they run. You want it to be reproducible, right? So you worked on this fancy pipeline over 3 months. You want to be able to reproduce that. You don't want to just share some Python file. You want to have some artifact that you can share with your colleagues. You can like improve upon yourself, put it in Git, things like that. And obviously, something I touched on earlier, you want to be able to scale. So you want to go from 10 records as you're experimenting to hundreds of millions of records. And of course, like this is just text. So you want to extend to other modalities. The world is increasingly multimodal. Like there's audios, there's video, and there's image. So you want to be able to handle that as well. And turns out, doing all of this is quite hard. So just a little bit about how Data Designer works. Data Designer is the package itself is the repository itself is a monorepo, has like 3 different sub packages in it: configuration, like config, engine, and interface. And It's designed with like separation of concerns in mind. The config one is the one that, as a user of Data Designer, would mostly use, and it has all the classes and abstractions that help you define a Data Designer configuration. And you'll see in a little bit what that looks like. Engine encapsulates everything that is necessary to be able to execute that at scale. And an interface, as the name suggests, has just enough classes and abstractions to help you execute a Data Designer configuration using the engine, so that the user doesn't have to worry about all the complicated stuff that happens inside an engine. And when you're thinking about a data set, you can think about it as just like a pandas data frame, right? So you have a data frame with a bunch of rows and columns. In this case, it's like docstring, coder style, code, validation. And what it really looks like as you're designing data is you start with some data that you already may have that you want to use as as a seed for your generation. So in this case, I want to start with some doc strings of code. And as I'm designing my data, I'm going to start adding columns. And essentially, you're sort of like defining the schema of your database, right? So that's how it evolves. So Data Designer comes with a bunch of column types. We'll talk a little bit about it later. There's a seed column types. There's samplers that give you structured metadata that you can use to steer your generation using LLMs. There are dedicated LLM-specific generations that you want to use. There's validations, validators, there's expression. And then if none of this fits, you can create your own custom plugin, like I said earlier. And in terms of the code, it kind of looks like that. And we'll dive into that in a little bit. But essentially, once you're happy with your Data Designer configuration, you would either do a preview or create. And what the engine does is it creates, it uses all the dependencies that have been constructed through your configuration, constructs a DAG, does a topological sort, and then figures out what columns can run in parallel, what columns have a chain of dependencies, and then it does a cell level async task dispatch at a cell level. So as you can imagine, like if you have a million rows, they're like a million times squared, right? Number of cells. So it's gonna dispatch all these, create many queues to execute that at scale. And we even have a middleware between our execution system and the model providers that help sort of react dynamically to back pressure signals that we get from model providers. So if you're getting a lot of like 429s from OpenAI because you're sending like hundreds of requests per second, then Data Designer can sort of like react to the back pressure and automatically adjust the number of API calls that it's making. So all of this stuff is really complicated, lots of engineering that went into it. But as a user, you don't have to think about that, right? And the beauty about Data Designer is it really lets you focus on what's really important, and that is the aspect of iteration that I talked about. So I guess experimentation is just like very scientific. What you want to do is you want to design your data, and what that looks like is you're going to add some columns, you're going to define what prompts, you're going to do some prompt engineering, you're going to change some sampler types, you're going to preview, you're going to look at the preview that you get, and if you're happy with it, you can create it at scale. But then if you're not happy with it, you're going to go back to the drawing board, right? You're going to iterate on that several times, and then after you're done creating at scale, you have your synthetic data set. But that's not the end of the story, because how do you know if the synthetic data that you generated is actually going to help move the needle in your downstream task, which might be fine-tuning a specific model, right? And what you want to do there is, okay, so I've generated my synthetic data. Now I want to train my model. Is it like SFT, GRPO, whatever? You take that step to train your model. Then you want to run some benchmarks, see if it helped. Is there a lift in the metric that you're looking at? If there is, great, right? If there isn't, then you want to do some error analysis, right? Like what went wrong, what helped, what didn't help. And that's going to inform your next Data Designer iteration. If you might find that it improved metric in a specific type of document, but it didn't help documents with, say, let's say like pie chart for whatever reason. In that case, you can go back to the design stage and add more documents as seed. That's going to help you generate more data that's going to specifically target the weakness that you saw in your model. So it's like a closed loop system where inside a loop there's another loop, and the exercises that we're going to go through is going to focus on this piece, right? Any questions so far that we can answer? Yep.
Do you also use this for property-based testing? Yeah. Do you also use this for property-based testing? If you want synthetic data to test your code, or do you use it only for training?
No, it could be anything.
Yeah.
You could use it for anything. If you have some type of metric that you're trying to improve, it doesn't have to be on the other side of model training. It could be for anything.
Yep. Yeah, and with that, we'll talk a little bit about anonymizer.
Yeah. Okay. So we went through this process. We generated synthetic data. We went through this closed loop system, and now we're deploying this model, which is typically what you want to do. But think like you have a model that's really good at, I don't know, analyzing PDFs for a specific purpose within your organization or like whatever field you work in. And it does really well on that. But some customers have expressed negative sentiment, or they'll be like, I don't know how many people use like Snowflake or Databricks, but they do this, right? Like they have something that's really good for their programming languages. And there are users of the platform who use their systems, and these are all like agentic, LLM based, cool. But many users are dissatisfied. I'm very dissatisfied pretty constantly because I don't really write SQL. I just write natural language, and I expect everything to work. And so I get dissatisfied. There's some sort of signal of that in the logs that they are collecting on the back end. And now because it contains a lot of PII, because I copy paste stuff, I have API keys, my name is everywhere, whatever, I throw it in, and now that's just like very rich with PII, and they probably can't use it to improve their models because I hope they have very strong data use policies. So what do we do with that data then, right? Like how do we make it usable? Do we just strip PII, say, you run some type of named entity recognition model, cool, it gets some things, great. Is that enough? I argue no, and that's why part of our team built NeMo Anonymizer. We use Data Designer as our backend, so it's a dependency. It's our only dependency, really. But what is it? It's a text anonymization library that's sort of built for the LLM era. So it allows us to transform the minimum set of details required to break sensitive inference while preserving useful meaning. And so a really good example of this is, let's say you have some text. It's unrelated to logs, but let's say there's some text in some sort of long document, and it says, Sarah described her appointment. She's looking forward to ringing the bell soon and said that the care team has been wonderful. Cool, I run some type of model on this, and it says Sarah is a first name, let's just redact it, or replace Sarah with Lipika. Cool, done. Except not quite done, because ringing the bell is actually a contextual clue. That's something you typically do when you're like nearing the end of cancer treatment, and that is pretty sensitive, right? It's like a very sensitive disclosure. You wouldn't catch that if you were just using an NER model. And so that's why we built NeMo Anonymizer. It's very, it sort of picks up the problem as a reasoning problem. So anonymization it really is a reasoning problem. And especially in this day and age, like think of logs. OpenShell is a new concept to literally everybody, including anonymization systems and to LLMs. So you have to like be able to sort of define some rules in natural language that you may not be able to programmatically and adapt really quickly. So that's why we built Anonymizer. Why do we need it? Hopefully you're convinced that we need it with that one example, but really it is that like privacy is contextual. There are a lot of like quasi-identifiers and data that do a lot of damage. Just combinations of different things can be incredibly revealing. And also in this day and age, I mean, come on, when you're stalking someone on the internet, like, you and I meet, and I'm like, oh, who is this person? I Google you. Do I really Google you? No, I just ask Claude, or I ask Gemini, who is this person? What do they do? How is their work relevant to me? And that's great, but I could also use it for a nefarious purpose, right? Like I could say, oh, here's some redacted data. Can you please find who this might be related to? Just search the internet. Then you have access to everything. So in the past, these used to be like theoretical attacks. They're not really anymore. Now I can do it. I have access to effectively infinite compute if I pay for whatever subscription, and that's great. And that's the case for agents too, right? Agents have infinite tools. It's not just web search. It could be like within a company. It could be you're part of a company that has a certain database, and then you got some external data, and then you want to do some sort of linkage, and it's helpful to you, and so you could possibly do it. And if they didn't anonymize their data in sort of the best way possible, maybe you could do some linkage. And so all of this is possible. It's really not theoretical anymore. And so when you deploy your model and you get some logs from it, and you want to use those logs to improve your model, it really is like kind of a responsibility to do it in the best possible way and to do it like in a contextually relevant way. Yeah, so how does NeMo Anonymizer work? It's actually really simple. We use a data designer backend, so like all the stuff that Navin was talking about, like async, like cell-by-cell completion, just being able to handle 429s, all of that, like we just benefit off data designer, which is great. And really all you have to think about is what you want to do with Anonymizer. Do you want to just find what was in the data? Do you want to annotate PII? Do you want to redact it? Do you want to hash? Do you want to substitute with sort of contextually relevant alternatives? Or do you want to just do a full rewriting of text? So Sarah completed her appointment. She's really looking forward to ringing the bell. OK, maybe you don't need to mention ringing the bell. She's really looking forward to thanking the care team, or she's very happy with the care that she received. Cool. That's a great rewrite. It still conveys that she completed her appointment and some sort of sentiment around it. Okay, so that's Anonymizer. Quick overview. We'll cover this actually like at the very tail end of the tutorial, and you'll see a lot of things that are very familiar because it's all built on Data Designer. So, all right.
Awesome. So hopefully, for those who want to follow along, you were able to set up or get set up. Quick raise of hands. How many are you set up with the repository? And OK, sweet. And if you don't want to do that right now, that's fine too. It's the repo is available publicly, so you can do it at home at your own leisure. For now, just feel free to follow along with me and just ask questions if you have confusions, anything like that. So we're going to go through.
And if you need help or like you haven't set up yet, just raise your hand and one of us will be over.
Yep.
So don't be shy, please. We're here to help.
Yep. So if you see this Jupyter Lab open up in your browser tab, you're in a good spot. So we're going to open up the first notebook, and it's called TextQA. And the objective of this notebook is to really familiarize ourselves with Data Designer, some key concepts, and then extend our understanding to implement a pipeline that's going to help us build visual question-answer pairs that we can extract from documents, right? That we can then use to fine-tune a VLM. And what this looks like at the end, like we're hoping to see a data set like this. This is like one row, table with one row. There's a title, topic, URL, and article, and you'll find out that the first four are actually seed data sets. So we use Wikipedia excerpts data sets, which basically are like little excerpts from Wikipedia as our seed data sets. We're going to generate some columns that have question ID, just so we can uniquely identify a question. We're going to sample some difficulty because we're interested in all kinds of like easy, medium, hard kinds of difficult questions we want LM to generate. We can fiddle around with question type, and then the generated question that is grounded on the article that's provided, and then the answer to that question, right? So in this case, it's a structure generation. We use Pydantic to define the shape of the data that we want from the LLM. And then finally, we'll layer in a judge layer to help us discern like how good the data is at scale. When you're looking at millions of records, you can't eyeball everything, right? So we have to rely on a proxy like that. And we'll learn some controlled, concept like that. So here's some text here that you can definitely read at your own leisure. Let's get set up. So let's look at the code. The first two lines of code are quite important for Data Designer, and we've put a lot of thought around usability of our API. So anything config related, this is sort of the pattern that we recommend that everyone follows. We just import datadesigner.config as DD, and that particular module config has anything you could possibly want to use to build a Data Designer plugin exported. So you can do down the line, you can do dd.datadesigner, for example, Data Designer config builder. So everything is on a DD. So you don't have like 20 import statements in your notebooks, right? You just want to focus on what's important. The second line is Data Designer. You're importing Data Designer object itself from the class itself from the interface module, and this is what helps you execute that particular config that you built. The rest are just these are just like helper methods that we made available for this particular exercise to make things easier for everyone. And then finally, we import Pydantic classes to help define our Pydantic class that we're going to use for structure generation. The provider here is just also convenience. We can set it auto. So if you have an NVIDIA API set up, it's going to pick that up. Or you can just Feel free to change it to OpenAI if you have OpenAI API key set up, or OpenRouter, but it doesn't really matter. For now, let me just use OpenAI because it's relatively faster among the three. For now, environment setup is going to just like read your environment files and everything set up. Show provider will show that, and then once you're ready to design your data set, you're going to want to create an instance of data designer config builder, and you're going to want to provide it a set of models that you want to use for generation, and this is how you do it. Model configs is, in this case, we have like a pre-cooked set of model configurations and model providers available for you for this exercise, and we'll talk about this a little bit down the line. And then you create a data designer instance, right? So this kernel is kicking up. Okay, it executed. It printed my model setup. So I'm going to use for this particular notebook OpenAI as a provider. Here's the endpoint. Like, it has its API key resolved, and these are the three models that have been set up. Text LLM, it's all pointing to the same model right now, but in reality, when you're working in production, you want to point to different models based on your generation needs. Some models are good at some things, right? So you want to point to the right model. Some models, some tasks doesn't require a big model. It can be a very cheap small model, so you want to point to a small model. And you want to fiddle with different things like temperature, for instance. Like in this case, we're pointing to the same GPT 5.0 model, but then we're using different temperature settings, because for text LLM, we're generating questions, so we want the model to be a little more creative when it's generating questions. But if it's using the judge, if we're using it to judge things, we want it to be more deterministic, more locked down in terms of the types of responses it can generate, right? And for VLM, it's a VLM as well, so we're going to use the same. And we're just doing that to make this exercise a little easier. So we have that set up, and now we have our config builder. The first thing we're going to do is we're going to add some sampler columns. And the way you do that is very simple. You do config builder.add column, and then you specify the type of column you want to add. In this case, it's dd.sampler column config. Right? We want to literally just add a UUID, basically. This is just like a convenience config. It's not really doing anything complicated. So we want to give it a name, and what this gives us is a column with that name, QA_ID, and we want to specify the type. It's going to be UUID, and we're going to give it some params so that this particular column generator knows how to generate this particular QA. And we want to say, okay, yeah, just like use this prefix QA dash, and then use a short form of the UUID and not the long 16 character one. So once we have a QA ID, we want to add some samplers, because we want to generate different kinds of question difficulty. And this is something you're going to have to experiment with, because what easy means may change based on what model you use. So you want to iterate with different models, and you might realize that easy is actually not going to be helpful because it's too restrictive. So you might want to have something else entirely to help guide the generation. One thing you'll see here with this particular categorical sampler is weights, and what you're doing here with weights is you're controlling the distribution of the sampling that happens, right? So in this case, what I'm saying is I want most of the data that's being sampled from this sampler to be a medium. So basically 50% of my questions that I want to generate should be medium difficulty or hard, and you don't necessarily need all of these to add up to 1. This all gets normalized, so it can be 15. That means it could be 100, whatever. This means you're going to have way more hard questions than, for example, easy. So just a quick note that it doesn't have to add up to 1. It gets normalized. Leave it at that for now. So once you have the question difficulty, we want to add another sampler column. It's called the subcategory, and what this lets you do is it lets you nest, add another category under the category that you already have. So for example, I want to be specific about what kinds of questions should be easy, right? So in this case, when it's easy, the question difficulty, when the question difficulty is easy, I want the question type to be one of these two: fact lookup, just quick lookup, or definition, defining something. Or if it's medium, it has to be relational. There has to be some relationship between concepts. And for hard, it has to be inference, right? It can't be just it has to be implied but not directly extractable from the text that we have. So this lets us control that kinds of distribution. Now let's take a quick look at that. But we want to validate that this config so far is correct. I get a positive signal that it's good. And Data Designer has a bunch of other types of samplers. We only use the categories on subcategorical, but you can easily print out different kinds of supported samplers, and they're really interesting ones. They're fancy, like Bernoulli's distribution that you can get. Category, date, time, Gaussian, and things like that, right? And the other one that's really interesting is person. I won't go into this in detail. There we have like a lot of posts about this in our dev note. I'll encourage you to look at it. But it's essentially a way to sample synthetic people that are based on real world distribution of like demographic information from different locales in the country. So you can get really specific about things like the example I gave earlier. Someone who lives in London with a German Shepherd who is like very anxious. You can get a sample like that, and you can guide your generation based on that. So feel free to explore that on your own time. So let's say that we generate, so far we're going to do a preview. So we want to preview the data so far. So you run datadesigner.preview, you give it a config builder, you say, okay, I want to see 10 records. And because we haven't used LLM so far, it's like almost instant, right? So it's just sampling a bunch of text. So we have a bunch of questions. We have sampled a bunch of question difficulty, question type, and this roughly follows the distribution that you defined here, the weights that you gave. And you can, feel free to verify that. It's not going to be evident when you're just sampling 10, but when you're sampling a lot more, it's going to be quite obvious. Get a quick summary on like what are the counts and what's unique and stuff like that. But once you have those, now we want to start to use LLMs to generate what's really important. And what we're trying to generate in this is the question and answer pair. So for now, first we're going to use a seed data set. So like I said, we pull this from, has like 50 Wikipedia article, like excerpts we pulled from Hugging Face and just like made available here. And the shape of that seed data set looks like this. It has title, topic, URL, and article. What we really care about is the article here. And we want to generate questions, synthetic questions based on that article, right? And you do that by saying we have the config builder object again, and we have this interface, this with seed data set, and then you give it a seed source, and it happens to be, for now, it's just like simple local file seed source, and there are different types of seeds that you can use to seed your data set. Feel free to look into our documentation for more details, but essentially we're saying, use this as a seed, and then I want you to shuffle it, right? So what this means is if you have a seed data set with 50 and you just want to generate 10 records, it's going to randomly select 10 from it, but you can also do ordered, right? And if that happens, then it's going to pick the first 10 as an example out of 50.
Or if you have a seed data set of 50 and you want to generate 500, then it's going to randomly sample with replacement.
Yep. Okay, now we added our seed data set, right? And now you can see the preview. It has seed, we have QAID, question difficulty. Now let's do a preview again. Let's see what happened after that. Now we can start to see our data set take a little more shape. So seed columns, we have, in this case, the title is Abraham Lincoln, topic is from Wikipedia, URL is like the URL where this article can be found, and this is a short excerpt article. And we have a generated columns. We generate the QAID, question difficulty. So for this one, it's supposed to be medium, and then question type is evidence summary. Now we want to start using our models, and a few concepts we want to think about is model providers and configuration. So these are like abstractions in Data Designer that help you inform Data Designer of how to talk to an LLM provider and which model to use, right? And sort of there's like similar concepts exist in all other LLM type libraries, but Data Designer already ships with a bunch of pre-cooked providers that you can just plug and play. And I can just like quickly show it to you what this looks like. So as an example, we have 3 different providers that are already baked in: NVIDIA, OpenAI, OpenRouter, and it's looking for specific API keys. Here are the endpoints, and we have different models that have been set up that we think are best for a synthetic generation use case, for specific use case like text generation or that requires reasoning, vision, embedding, and we have those for all 3 providers. And you can see like inference parameters that help you control the temperature, top P, how many requests you want to make, and additional like reasoning effort type parameter that you want to give to the model provider. But for now, like I'm just showing you what Data Designer ships with. But for this exercise, we're like we're pre-cooking it with like specific models that we have control over. So in this case, I said like we want to use OpenAI, so it's just showing OpenAI specific configurations. But you can take a peek at that like that. But in real world, what you want to do is you want to be specific about what model we want to use. You might want to use the one that's on OpenRouter, or you might want to host it on VLM somewhere in your Kubernetes cluster or your Slurm cluster, or just your local machine with the GPU. In that case, you can just define it like so. You can give it a name. You can give it an endpoint. It can be this some endpoint that's like behind some load balancer, or you can be your local host, right? Or if you have, if you're running it locally. Provider type just tells you is it OpenAI API compliant or is it Anthropic? And then you provide your API key here, or you can say this is in this environment variable so the data designer knows where to look it up. So here you're defining three provider and two different types of models. And then you can just give it to your data designer object and data designer config builder like so. This is just an example. It's not actually going to do anything. So any questions so far on those two concepts? Okay, cool. We'll move on. So now the meaty part is like how do you actually start using these different samplers to condition the generation, right? So let's look at a quick prompt. So the way it works is, you add another column and you give it another configuration. This is going to be LLM text column. I'm going to give it a name for that column. It's going to be question, and the prompt is going to be question prompt, which we'll dive into it a little bit later. And then with model alias, we're saying actually what we're saying is to generate this question, here's the prompt, and by the way, use this model with this alias, right? And then we define that up here, right? So it's going to be text LLM. That's how data designer knows how to use that model, what parameters to use, and how to talk to the provider that's hosting that model. The prompt template itself is a Jinja template, so you can express relationships between columns with Jinja expressions. So in this case, I'm saying, okay, you are an expert at writing, blah, blah, blah. Here's the article excerpt, and you can find this in a column in an article, right? And the question difficulty should be this. Question type should be that. And you give it a bunch of instructions, guidance, and other things like that. You'll notice that I'm saying at the end, the output I would only return the question text, nothing else, because it's an LLM text column config. It doesn't do any post-processing. And sometimes LLM can be quite chatty, and it will say instead of saying the answer is, the answer is 4, instead of saying 4, it will say, oh, by the way, here's the answer. It will add some commentary. So you want to add some instruction for these kinds of generations. So we add that. And now we have our question. We want to generate an answer for that. And for that, we use LLM structured column config. And what this essentially lets you do is define the shape of your output that you want from your LLM to be a Pydantic class, or you can write a JSON schema as well. But essentially, it's a structured output, deterministic structured output. And what this gives you is internally, data designer has retries and like repair loops that help you make sure that the output that you get is actually a structured output that you define up here. So I'm saying here with LLM structured column config, so I want to generate answer, and here's the prompt. I'll open that up, and I want to use the text config. And by the way, the output format should be the answer, which is the Pydantic base model. And I can say with trace equals like all messages. What this essentially lets you do is like look at all the conversations that happen with it with the LLM within the scope of that particular generation in a separate column. And the prompt sort of looks like this here for the answer. We're just saying you are, it can be anything, but in this case, like you are answering this whatever question. Here's the article, here's the question, and then some instructions on how to answer that question. And what you'll notice is like there's no instruction here, additional instruction here that helps with the structured generation, and that's all handled inside Data Designer as long as you use LLM structured column config. Now let's add that to our config. So before we, so now we have our question and we have our answer. We can obviously eyeball our question and answer and cross-reference them with the provided, the excerpt to make sure the question and answer are correct. But you can't do that at scale, right? Like maybe at scale of like 10 to 100, maybe you can do it here and there. But when you're generating hundreds of millions of these, like you want to sort of like way to automatically do that. And the way to do that is adding a judge to do it, or you can do it. You can have multiple judges and do an LLM as a jury if you want to. It really depends on your use case. But as a simple example, what we want to do is we want to add an LLM judge column that's going to help us decide whether or not that particular generated question or answer is of good quality based on our scoring system, right? And what this particular system interface allows us to do is very simply say, okay, I want to add another column named judge. Here's the judge prompt, and I'll show that in a little bit. I want you to use judge alias, and here's how I define my rubric, right, on how to score. And I want to maybe define faithfulness, right? And It could be like pretty soft. It depends on how you define it. But I want to give it a concrete description of what this means, and here are my options. And we'll look at that really quickly. And completeness in terms of answer. So what it looks like is in the judge prompt, all I'm saying is you are an expert, blah, blah, blah. You have to like sort of inflate the LLM's ego a little bit. You can say pretty please a couple times as well. Sometimes that works. But yeah, you're essentially saying here's the article, here's the question, and you'll see that because answer is a structured generation, I'm actually accessing it like a property, right? In my Jinja template, I can do, hey, the answer is answer.text because the answer generator has two different things, the answer and the justification. But in this case, we already only care about the answer part of it. And the descriptions are here, and we have like a 1 to 5 rating system that progress like higher the better, right? So you can take a look at that a little bit later. But let's add that. We've added it to our pipeline, and now we're ready to do a preview with the full sort of flow. Okay, so you'll see a bunch of logs, and Data Designer is pretty verbose when it comes to logs, and we'll find some Easter eggs in terms of emojis there, which is quite fun. But you'll see it's doing some health checks. It's going to confirm the inference parameters for different column types, and it's going to dispatch these jobs into tasks to run things in parallel when it can. Otherwise, yeah. So you get a progress report on how many completed, how many are still pending, and at the end of the day, it's done so far. Now, once I have a preview result, what I want to do is I want to simply see what's going on with the generation, right? So it came back with 3 records. I think I asked for. It came back with 3 records. So in this case, the title is algae. Here's a URL and some article about that, and it generated. It sampled these columns. It generated this ID, this question difficulty, this question type, and here's the question that it generated. Let's see. What details show that algae are a very diverse group of both their biological classification and their physical forms? I wouldn't be able to answer that question or generate that question myself. We don't have time to verify that, but let's just assume that it's correct. And let's rely on our LLM judge to get that proxy, right? So, and the answer that it generated is quite long. Because I don't know. Okay, so sort of like one thing question type. Question type is evidence summary. Okay, that's why it's giving us sort of a long answer, because it's providing evidence as to why, and there's some justification. But our judge says it gave it a score of 5 in terms of faithfulness, and gave it a completeness score of 4. So you want to sort of like use this to sort of like at scale get a handle on, or get a sense on how good that is. And also just to like, you want to be pretty aggressive about filtering out bad results, right? You might get like a percentage of your data that you generate that's going to be not going to meet your bar, right? So you want to filter those out. So you want to oversample and then filter to keep only the highest quality data set, because we want to keep those. That's yeah. And the answer trace is something we get because of right here. We want to see all the trace messages, and you can see the actual prompt that gets sent to the LLM. The LLM responds with some reasoning stuff, and it finally gets the answer of text. You can keep running this particular display sample to cycle through the examples. So I'm going to get a different response here. This one's a different one. The income of a nation's population. This doesn't look like a good question to me.
No, that's the answer.
Oh, that's the answer. Oh, yeah, sorry, yeah. Well, the question is, what is the per capita income of arithmetic average of? It doesn't sound like a great question either way, but the answer is the income of nation's population. So, you want to sort of look at these, eyeball it, and then sort of tweak your prompt in your judges, in your generation to maybe weed those out. Maybe who knows, this question may not be good for you, or it depends on the use case. But it gives you a sense of like what this iteration looks like. And you can also provide a specific index to like take a peek at that record. And let's say that we're happy, we did it hundreds of times. Now we're ready to scale it up. Like in this case, for the sake of time, I'm just going to say I want to generate 20, and I'm just going to let it run. So it's going to go through its thing. It's going to do the most optimal thing, yeah, the inference side of things is like we're really it's active area of research and work to make sure that Data Designer is optimizing the downstream model provider in terms of saturation, or if you're like hosting your own LLMs, is trying to maximize the GPU usage so that you get the most, you get the most tokens per dollar, right? So in this case, it came back pretty quickly, and I've generated my 5 records, 20 records, and we're done. Right, so, and we have a judge filter for a reason, so we want to filter out the ones that are bad, and in this case, like I have a simple apply function that's going to filter out anything that doesn't meet this requirement, that the score has to be at least 4 in both of those. And turns out like we only kept 1, so there's a 95% keep rate, which is pretty decent. So we're done through this. Hopefully this gives you a sense. One thing I'll note is that we also, like, if you're happy with this, you can automatically push it to Hugging Face. This was actually a community PR that one of our community members provided. So it's as easy, pushing to Hugging Face is as easy as running, push to hub. I think I got my repo URL incorrect. Yep. Okay, yeah. Oh, permission denied. Okay, let's oh, I see.
Get the right username.
Yeah, exactly. Yeah.
Yeah.
There you go. Oh, still working. Anyways, let's skip this for now. But essentially, like, what this will give you is like it'll push to hub.
Yeah, so that's an easy way to share the dataset artifact that's created, right? And you can share with your team and so on.
Yeah.
But then you also just like push this code, and then that's in fact almost like a better artifact, because then your team or colleagues or friends can generate much more data that's just like that.
Yeah, here's an example of what that looks like. So this is another data set. This is an example data set. Once you upload it, you have your data set viewer. You can use Hugging Face's API to inspect the data set. In terms of files, it uploads all the Parquet files that have been generated. You also have the reproducibility aspect of it. The builder config codifies all the configurations that you built, so that next time, if you want to share it with a colleague, they can just take this config and start from there to do the generation. Any questions so far before we move on? Yep.
So I was just wondering, I've tried eval before, which has a synthetic data generator, and one of the challenges I encountered was if you want to create a lot of data, you plug that into your normal API CMS, and then you hit the ring.
Yep.
Try to scan everything through.
Yep.
So do you have
Yes.
plugins built to like batch processing for like
Yeah.
scale of data?
Yeah, so that's a great question. And so one of the things we touched on earlier with when setting up your model configuration is this idea of, where is it? So when you're setting up a model configuration, you have control over what you want the maximum parallel request to be for that particular provider, right? In this case, it's only 8 because I want to be conservative, but you can slam it with, if you set it to 8,000, right? This is going to slam that API, but Data Designer has middleware built in that's going to react to the back pressure from the API provider. If the API provider is Anthropic or whatever, and they give you 429s, Data Designer is automatically going to use this algorithm called additive increase, multiplicative decrease to manage that throughput and throttle the client itself. I had a diagram here somewhere. Here, right? So I don't know if you can see it, but at the bottom, so we started with like 20, but then it got 429s. It dropped, right? So, but we want to like try to climb that hill again to see what that optimal throughput is. We're going to get 429 again. We're going to go down, and then ultimately it's going to find the right balance in terms of API rate limit for that particular time, right? Because that changes based on what the traffic looks like for the provider itself. If you're not using Anthropic, you're hosting it on VLLM, for example, it's going to react to the queue depth of your VLM signal that VLM provides. So it works similarly, but yeah, it's nice that you don't have to like sort of tweak, what the throughput looks like. All right. Any other questions? Okay. So the next notebook is going to be quite simple because you already understood the basic concept around Data Designer. Now what we're trying to do, again, as a reminder, is our objective is to build visual question answer pairs. So we have documents with different kinds of images. It could be multiple pages, but in this case, for simplicity, we're going to deal with just one-page documents. And we want to generate synthetic question and answers that are going to be challenging for a VLM to reason about to answer that. And the reason we want to do that is we want to train another VLM that's maybe smaller in size, right, compared to the one that we're going to use to generate the question and answer. So in another way, we're like trying to distill knowledge and information from a larger model into a smaller model, give it the skills. Maybe because, you know, like smaller models are cheaper to run, right? So instead of using, you know, for example, ChatGPT, if I can fine tune, you know, a Quen 8 billion model, and I give it just the amount of synthetic data to improve on a specific benchmark, then I can do the same work. You know, we're using a smaller model. Maybe it runs on a laptop. Doesn't even need GPUs. Maybe it runs with Llama CPP.
Also, if you did want to run a notebook and you did want to do something live, this one is quite a fun one. It's got like images. It's quite fun.
Yeah.
So I'd recommend.
Yeah. So we'll get through this here. So the shape of this data looks like this. There's a base 64 encoded version of image in every cell, and this is just to make our demo sort of easier. In real world, you want to deal with like file paths. So this will be a path to a URL. It will be a path that your inference provider has access to, or it'll be a URL that the endpoint has access to. For now, it's base 64, so we don't have to deal with scale at this moment. So we're just taking the easy way out. So there are some like information on what's in that particular image. So this image looks like it has a primary visual is about stacked area, chart showing, has some chart category mixes and things like that. And these, turns out, is actually a categorical value that I have provided. There's a bonus notebook here called bonus generate documents. And the images that you're going to see were actually generated using that data designer notebook. And these were the seeds that I used to generate diverse set of synthetic documents that I want to use to actually improve my VLM on the specific task of improving on document reasoning to be able to answer questions, right? And it's a bunch of seed questions, and same fashion, I want to generate some question types, short answer, long answer, and you're going to have to experiment this to fit your needs. But for simplicity, we're just going to go through some simple samplers. Sorry, okay, yeah. And question difficulty, we're going to generate visual focus, and I'll explain that why we need to do that in a little bit. Then we're going to generate a question, the answer, and then the same flow of a judge to help us get a sense of like how good it is, and then we'll have some columns to help us iterate a little quicker when it comes to failures. So here's the pipeline. We'll do the same thing, right? So we're going to import a bunch of things that we need. We're going to use OpenAI right now, set up our environment with API keys. Okay, so we're going to use OpenAI. We're going to use GPT-5.4. And let's inspect the seeds. So in this case, it's a document. It's a data frame with images encoded as base 64 strings. In this column is named PNG base 64. It has a bunch of seeds around that. Let's actually see that image. In this case, okay, it looks pretty complicated, right? So it's actually quite amazing that we were able to synthetically generate this image, which looks pretty good as like a business document that you would have, in the real world. Let's look at the second one. Let's see. I think there are like 25 examples here. Let's look at the third one. Okay, this has a bunch of like text, some titles, some charts. Let's see another one.
It's also pretty diverse, right? Like that was a clinical trial report. The one before that was energy consumption.
Yeah, this is clinical trial 2. Has a bunch of tables, just tons of information that is really hard as humans to be able to interpret what's going on here, right? So imagine being an LLM with, all you're looking at is like image tokens.
Or this is like a negative example in a visualization textbook.
Right.
Do not visualize like this.
Yeah. So this is what the data set looks like, and what we want to do is we want to create some question answer pairs. So we're going to ingest that into data designer. Similar to how we did earlier, so we're saying like, here's our config builder, here's a data designer. You can gloss over this for now. It's like a mechanism to help us with failures. With C data set, we want to point it to that, and in this case, we're going to do ordered because I want to generate like one question per image. You can do it random, shuffle as well. If what that means, if you can shuffle, is that you may end up sampling the same image, and you will end up generating a different set of question answer pair for that particular image. For now, we'll just do ordered as a variety in example. Okay. All right, so we set up there. So we're going to add our samplers, question type. We want to generate multiple choice, yes or no, short answer, list of items. We want to weigh it this way. Question difficulty, easy, medium, hard. Let's add another. Let's just for fun. Let's see what happens with super hard. I don't know what that means. What's the distinction between hard and super hard? So LLM. So if you give it an LLM to interpret what that means, you're going to get very different response. So you're going to have to guide the, in this case, give examples with subcategories. Okay, what does a super hard question look like, right? And let's say I want it to be super hard. Let's see. Okay, so have that, and now what you'll find is that the way you would deal with images is quite simple in terms of plumbing it into a data designer workflow. But before that, what I want to focus on is one thing you'll want to worry about, think about working with images, VLMs in general, is that there's a lot of information in images that if you ask an LLM to do a lot of things at the same time, it's not going to give you the best result. And also, based on the task, you might find that a smaller model is actually quite fast and sufficient to do a specific task. For example, if you were to look at this document and you don't have any context, if you just said, hey VLM, generate a question answer pair, it's up to the LLM's imagination to come up with a question, and it's gonna give you some easy almost cheating type of question. It could be what is the color of the cell that has this value 210? It could come up with that, which is quite simple, right? And it doesn't require any reasoning I mean, it does require some reasoning ability, but it's a comparatively very simple question. So what you want to do is cater your prompts to the things that are inside an image, and to do that, you might want to do some classification, right? So take that image, run it through a VLM that says, okay, what are the important visual elements that you can identify in this particular image? It could be tables, charts, right? Dense text, or pie chart, things like that. You can be as specific as you want. So what that gives you is then in the next step, when you're generating the question, you can tailor your prompt to say, okay, yeah, this image actually has a pie chart. Now generate these kinds of visually intriguing questions that involve comparing areas of chart, right? So you can condition it like that. So you might want to do that. And actually, if you look at one of the blog posts that I mentioned earlier, where we improved the long document reasoning of the model, that's exactly what we did. We had built a giant taxonomy of different types of things that we found or detected in those images, and then we used those to condition the further generation of question answer pairs that ended up yielding better question answer pairs. So where are we? So in this visual focus, what we're trying to do is we're trying to identify the focus area should be, and what should the question be? What is the interesting area in this particular image that I want to base the question generation on, right? So I'm saving it in a column named visual focus. This is my prompt, and you can take a look at that prompt a little bit later. I want to use a VLM. I want my output to be structured. I want it to give me this structure. And by the way, the image should be and the multimodal, the way you tell a VLM you should use images is you can just do multimodal context, and you give it an array of image context. So this is the abstraction that helps you wrap around multimodal data. It can be dd.image context. Right now it's PNG, but it can be URL, and you don't need to do that. But it can be a URL that the model endpoint should have access to. You'll see that data design is also capable of handling audio and video at the same time. So in the same context, you can do things like dd.audio context, like that. If you're working with an Omni model that can generate this, handle this modality. But for this case, we're using GPT-5.4, which only handles images. So this is how you give image context to a column generation task. So we added this visual focus, and now we want to add a question. And if you look at the question prompt real quick, visual question prompt, it has condition on here's the question type, here's difficulty, right? And you're supposed to focus on this particular focus area, and it has some guidance on like, oh, based on if the focus area is chart, ask about chart value, axis, labels, legend, category, trend, and outlier, stuff like that. So you can like control the behavior that way. Okay, so QA judge, in this case, I'm just showing you, like, you could use the LLM judge as well, but you can also just use LLM structured column config. The reason I'm showing you here is that based on, sometimes VLMs can be finicky about generating structured data, and in that case, like, the simpler the schema of your of the shape of the data that you want to generate, the better. So we'll do that. And one last thing we want to add is called failure review. So oftentimes what happens is when you're generating at scale, you'll have a bunch of data, and some of the values that you generate doesn't make sense, and you want a quick way to get an insight into what's happening. And to do that, you can add another LLM to do that work for you, right? And in this case, what we want to do is we want to do conditional generation, where we want to say, okay, actually, I want the failure review on this particular rows and what went wrong, but only do it if the VLM flagged it as something that's problematic. So we can do something like skip generation of this particular cell in that row when the judge marked it as passed. So if the judge said it was a good record, pass it. Otherwise, I want a detailed report on what went wrong, so I can later go in and figure out what's going on. So let's run this. When working with VLMs, you'll notice it's a little slower than regular LLMs because there's an extra vision encoder that has the image and image has to go through. So it's a little slower, but we'll run preview. So it's doing the same thing. So everything looks familiar. All right. Okay, it's generated focus areas. It's going to generate questions. Any questions I can answer while we wait?
Yeah, anyone need help? I'm back here too.
Okay. Okay, so it's almost there. Now we're done. So in this case, this is the image. This is the first index, yeah. Here's the generated data. I actually have some helper method to help visualize that better. So let's take a look at that. So here's the image. I think we saw this earlier. And the question here is, on the trial enrollment versus site complexity scatter plot. So this is the scatter plot. So you can see that the VLM is able to read this and figure out that this is a scatter plot. Which labeled outlier annotations are above 500 total enrollment mark? List them from left to right. So you can think, like, as a human, if you were to create this, like, if you were to label, if you were to get this image and you were to create this, like this question yourself, you can imagine how long it would take, not just to generate, but then, like, even if you were just like generating an answer, you have to read the question. It's going to take you several minutes to make sense of what's going on in this image, and then come up with an answer. So in this case, the LLM thinks that the answer is Tallahassee high complex role. I don't know if these are the answers. In this case, the judge didn't flag it as problematic. We'll take a look at that later. But you'll want to do this a couple times and get a feel for how the LLM is behaving, because every VLM is different. But let's say that for the sake of this example, this is good. We're happy with that. And the same thing we talked about earlier, we can run it at scale, and we can filter out the bad records. Just a few more things I want to point out. It's easy to say, okay, I want to generate 1 million records, but things always go wrong when you're doing large-scale generation. But Data Designer has built-in features to help you tackle those interruptions, right? So if things fail, you have a bunch of completed records, you can always resume it, and it's going to pick up from the last checkpoint that was saved, and you can take it for a spin at your own time later. And I have a few slides here that talks about how to partition a large job. So let's say you have, you want to generate 10 million rows, but you want to generate that across many different jobs that can run in parallel. And Data Designer has abstractions that help you partition the seed data set so that you can run independent Data Designer jobs. Maybe each job has its own inference stack, so you're not competing for the model endpoint throttling, the rate limits, etc. So yeah, take a look whenever you get a chance, and with that, I'll pass it on to Lipika to talk about Anonymizer.
So it looks like some people are having success running stuff, but
Okay.
I also just wanted to say, Navin pointed to this bonus notebook, and I also added a bonus notebook. But basically, even if you're doing a demo, you could use Data Designer to generate the data for the demo or for this type of synthetic environment. So it's not only to improve model performance, which is what we do in our daily jobs, but it could be literally anything else. So like the use of this is sort of limited by your imagination almost. Okay, so let's say we generate. Oh, go ahead.
Like, is it possible to generate data in?
Just 1 sec.
Is it possible to generate data in a very lightweight way? So I'm thinking, for instance, for development purposes, we sometimes don't want to use production data from the database, and but we also don't want to call like some LLM provider to feed our own data to generate data. So we want to generate some data locally.
Yeah.
Mm-hmm.
Have you any experience with that, or does it require really powerful models to generate dummy data, basically?
No, I think Navin's example is actually good. Like VLMs are generally slightly less capable in doing like everything than just an LLM, right? So I would treat that as almost like you have a less capable model. You just have to be more intentional about how you're seeding data generation. And it depends on what you're trying to generate too. So if it's like code or if it's logs or something, they have some inherent structure, which is really great, because then you can almost like constrain the job, and you can constrain your like data designer config, the whole thing from start to finish. We've had success using small models. For instance, like yes, we're using GPT-5.4 right now, but we use Nemotron Nano, which is a 30 billion parameter model with much fewer active. It's a mixture of experts, so much fewer active parameters. And then we also have success using just like 20 billion parameter models, and even smaller. Even Gemma models, to be honest, are pretty good. It's like 2 billion, 1 billion parameters. They tend to work if you're very specific about what you want, and you have enough like sampler columns to generate diversity. So yeah, small models work quite well, but you have to be a little bit better about how you write your config. Oh, and then the other thing is like, yes, we've gone through this, and you'll be like, okay, I'm going to pick this up, and I'm going to do, import datadesigner.config as DD. You could do that, or you could use the Claude Code skill, and use your favorite like agent encoding system. There's a skill for data designer, and so you can just describe in natural language like what you're trying to build, and it'll help you build a nice config, and then you can iterate on that, because now you've seen what the config looks like. So you'd be able to tell, oh, I need to make this tweak. I can probably just do it in code, or I'll just talk to Claude and do it. So you could just use the skill, and it's almost like you get this all with natural language.
Yeah, that's a really good point. I forgot to mention, we built this for humans to be able to iterate really quickly, but turns out that gave us like it turns out agents like that too. Like agents are really good at picking up data designer and using writing data designer configuration to solve a specific problem. So I'd encourage you to do that. And the other quick tip is like agents are really good at writing prompts. So if you're like having writer's block in writing prompt, just prompt an agent. They're really good at writing prompts.
Okay, so we have about 10 minutes. I'll go through this really quickly. This is basically, I made a bunch of logs data. It's also made with Data Designer, but it's similar to the type of data that we get from, let's say, build.nvidia.com, because we host a lot of models there, and people use it sometimes for free. So yeah, that's the inspiration for the data set that I created. We'll just run this through with, okay, maybe this is the notebook. All right, so this doesn't have any output.
Might be, is it this one here?
I think that has output.
Okay.
Yeah. Okay. Okay, so we'll just go through. We actually don't have that much setup to do. It's the same as Data Designer, so we don't have to set up the providers and the like where the endpoints are, and like actually selecting the models. It's like all very similar. We built some helpers to do this. It's just slightly different in Anonymizer, but different in the sense that like it's additive. There are a few more things you have to define, but I'll talk you through that. So let's load some of the logs data. I made 20 rows of logs, and this is sort of like, okay, you have a VLM, people are providing like documents as context, and they're asking questions about it. So like the thing that we were trying to get better at using the data set that Navin created. So there's a bunch of like interaction and stuff in there, but there's also a lot of PII that enters logs. So for example, in the system prompt, a lot of agents will be configured to pass the user's name, email, employer, maybe project code name, and it does show up in almost every single log line. It's different if you use like OpenClaw, it's different if you use a custom agent. We have internal agents that do different things, but they'll all have like a lot of PII in there. Then user messages, like for example, I copy paste code that has API keys in it, whatever. Because I trust that on the back end somebody is not looking at that and using it. Then there are tool calls. So that'll be like looking at documents elsewhere. So it's going in, it's going in looking for things that a user may not even know about. And then tool results, and that's definitely going to contain things or contain PII that the user never typed. So like contacts, emails, reviewer names, that type of thing. So you wouldn't even like think about it, but it shows up really often in logs. Okay. So here's an example. I'll just go through the conversation trace. There are a few other things in there. Those are like the seed columns that I used with Data Designer. But for example, here's KPI Copilot, a SaaS business document analytics platform that summarizes dense reports. The user says, what are the key funnel metrics for Neotel's low entitlement offering in the EMEA segment, something, something. And then the assistant does a bunch of tool calls and responds Alex based on the market research brief, because Alex is the user who asked this, and so on. So this just keeps going, and some of them are much longer than others. Typically, our conversation traces, as a user, I tend to go to like full context before I stop a chat, which is maybe bad practice, but we find like it's really variable in our internal logs. Like we can get really short conversations in anything that's like 200 million, 500 million tokens, just like really, really long, especially agentic traces. Okay, so that's what we're dealing with. We're trying to basically catch everything in here, and in this particular example, replace it with something that is that's equivalent. So like we want to get Sarah Chen and replace that with something else, which is somewhat easy, but there are other things that we find. So we'll see what those are. Okay, so we'll configure Anonymizer. Again, there's this concept of providers, and there are several models that we use to be able to identify entities. So we use Gleiner, which is an NER model. It's very lightweight, which is why we use it. You could certainly use anything else. We also have a validator that just checks that like everything that the NER model found is valid. They tend to find things like substrings within words. So for, let's say, in the word or in the name Narbin, they find Narbin, but they also find IN, and they say, oh, that is the state code for Indiana, or that's the country code for India. So it'll find all of these things, and you have to sort of disambiguate and figure out. And so validator is really good at that. You could use like a regex type of situation there as well. Then there's an augmenter, which says, okay, well, I prompted this NER model to find a set of 50 things, but is there anything else in the possible like universe that you could find that could be sensitive? And so that's what the augmenter does. And we have a model that goes and generates substitutions for all the entities that were sort of final and good. And a judge, as always. We love judges, very helpful. Okay. So we set all of that up, and you can see this config looks eerily similar to what Navin just set up, because we use Data Designer as our backend. And we also specify which models we're selecting in this same config. The main thing, so like Data Designer is full of prompts that you engineer. The only thing that you really need to specify for Anonymizer is what is in your data. You could have an LLM summarize it. Really often, when I'm using Anonymizer, I'll just ask Claude, can you summarize this data set for me? And sometimes for logs, it's really good. Sometimes it's like very generic. So yeah, so you kind of have to figure out like how to write that well. Okay, and so we're going to look at this conversation trace, and we're going to try to anonymize that. So you can see the logs. I actually made this kind of verbose because you all have seen data designer logs, so they should look very familiar. But we're using a kind of oldish model, GPT OSS 120B, which is not exactly small, but just to demonstrate that even older models do well when you structure the task really well, which is what we've done here for anonymization. Okay, so it's going to do the thing, and we're probably going to run out of time. But basically, the takeaway from this is you can do all this, and I'm going to just show you a run that's already completed. Okay, so we ran through this. This one ran with OpenAI models, and this is the same type of progress chart that you see in Data Designer. It's great, great, great. I also want to evaluate to see, did we actually find everything? And of all the PII that we found, is it actually valid? Because I barely configured this thing, right? Like I just said, choose these models, and then here's what's in the data, kind of hand-wavily. And here's an example record. So this contains KPI Copilot, tagged as company name, sure. Emails, that's great. People analytics lead, occupation, kind of, it's a title. EMEA, place name, kind of, geographical region. Cool, cool. It's done a bunch of stuff here. This is just our first pass, by the way. And we can see there's several things that are flagged here. So, all right, 95% is a percentage. It's tagging it as a false positive. And so our judges are really helpful here. The point of showing this is like, then you go back and you iterate and you say, in the data summary, what's actually in here. It turns out there are many, many different types of logs in here. So we find it much more effective to like separate out different themes of logs and then treat them for PII. But there's a lot of fun stuff that you find as well, versus doing something like just looking for or looking with regex, for example, for email address, phone number, and so on. Because you get a ton of false positives, but like really bad. For example, what the regex matches found was 18 phone numbers. There are 0 phone numbers in these logs, but it's just matching like long numeric sequences. Whereas what Anonymizer found was a lot more. Document IDs, ticket IDs, place names, date times distinguished from dates, and so they get sort of different treatment and so on. All right, so that's sort of how we do better, but we can do even better when we iterate. And again, there's a skill. You can sort of use it with Cloud Code, and it does really well. So you can iterate really nicely and just look through and see what you're actually trying to find. And it's also super customizable with like agentic traces. So as you use like different agents, or as you make different agents, there's just different type of PII that seeps in, and the structure looks very different. So it's quite adaptable. All right, I'm going to stop there because we're almost at time.
Yeah.
But any last questions that we can answer? Anything that worked well or didn't work well with your notebook setups? Go ahead. Oh, one second.
For evaluation, mostly we use the LLM as a judge, but is there a more deterministic framework which we can use for evaluation, say, for example, the numbers that we're extracting, or maybe an LLM pipeline?
Yeah. So within, I think the question on the answer can be both for Data Designer and Anonymizer. You can sort of define anything. So you can say like, here's a piece of code I want to run to verify. So you generated some code, you want to verify that it runs, you can verify that. You can say, there's some sort of system that checks it, you can plug that into Data Designer versus with these things called custom columns. I think that's the best way to do it. With Anonymizer, when you're trying to like check for a phone number, sometimes, you can sort of codify it in some type of code, or you can use a different tool. So for example, if you use like Presidio, you could plug that in the front end, or you could plug it in the back end, or yeah, you could use anything. So it's like very composable. You can use this in addition to other steps, or you can just use like a whole suite of judges. You can use like 10 different judges and then compare, that type of thing. Yeah.
Awesome. So, well, thanks so much for listening.
Yeah, thank you both. Excellent talk. Very interesting. Can we have a round of applause for our speakers, please?
Thanks.